So today we're going to be talking about functions, what makes a function, different parts of a function, and how you can determine if a relationship is a function. And so let's go ahead and get started. We are going to start by talking about the different parts of a function. So the first thing we're going to mention is the domain. The domain is the input for a function. So the things we put into a function, sometimes they're called the x values, and sometimes they're called the independent variable. The independent variable is simply saying that it doesn't matter anything else. We can put anything we want into the equation. So the input is what we stick into an equation. Then there's a rule, something we do to the input values to get the range. The range is the output values. And so we have the output values. Sometimes they are just referred to as the y values, and they're the dependent variables. And the reason we call them the dependent variables is because the output depends on what you put in for the input. And so these are completely dependent on what you stick in as the domain or the input values. So we're going to be using these four different terms interchangeably. The domain, which is the input, which is the which is the x values, which is also the independent variable. And the range is the output or the y variables or the dependent variables. And then the rules could be a whole bunch of different kinds of rules, but it is some type of an equation. And the types of equations are various. These equations could be linear, which means they just, when you graph them, they make a line. They could be quadratic, which means they have an x squared term in them somewhere. They could be an absolute value function. We've talked about those a little bit this year. They could be something that's called a cubic equation or an exponential equation. But there's some type of rule that we do to the input values to make them become an output value. And those are the three parts of a function. So what is the definition of a function? The official definition is this. It's whenever we have a relation, when a relation is a function, it is when every input value, so every x value, gives you exactly one output value. So we could say that for every x, there's exactly one y value. Or for every domain value, there's exactly one range value. But the key is that whenever we stick a number in, we know exactly what is the one number we're going to get back out. And if it gives us one number, then it is a function. So here are some examples of functions. So we can talk about a waiter or a waitress who makes tips. And so let's say that they work for 3 hours one evening, and we want to plug in 3 hours and then use a rule to figure out how much money they're going to make. Well, if they just make tips, we don't really know how much money they're going to make, because 3 hours one night, it could be $20. 3 hours the next night might be $50. So this is not a function because we don't have exactly one value that's coming out every time we stick in a number. Now, if we change the situation and say there's a waiter or waitress that makes $8 an hour, and then we plug in 3, well, if they make $8 an hour, we know they're going to make $24 because 3 times 8 is 24. The rule would be that you multiply the input values times 8 and you get exactly one output value. So that is a function. Another example that you can think of is a vending machine. Let's say that you go to a vending machine and you want a certain candy bar, so you plug in D3. So D3 happens to be a certain candy bar, but let's say there are several D3s. And so you don't know what candy bar you're going to get. That particular situation would not be a function. However, if you plug in D3 and out comes your candy bar that you want because there's only one D3, let's say it's a Kit Kat bar, then that is an example of what a function is, because every time we stick in or we plug in the input of D3, we know exactly what we're going to get back out. This is what this is going to look like with some input and output values. So we have 3 examples here. Example 1, we have our input and our output. So when I plug in a 1, I know I get a 4. When I plug in a 2, I know I get a 6. When I plug in a 3, I know I get a 5. And when I plug in a 4, I know I get a 7. So is this one a function? So this one is a function. And the reason we know that is because every time we plug in a number, we know exactly what number we're going to get back out. Let's take a look at example 2. Now, we could go input and output, but in this case, we're calling it the domain and the range. But it's the same thing. We have the input values and we have our output values. Let's see if this is a function. When I plug in a 2, I know I get a 6. When I plug in a 4, the one number that I get back out is a 7. When I plug in a 5, the one number I get back out is a 3. And when I plug in a 9, the one number I get back out is a 3. So is this a function? And yes, this is a function because every time I plug in a number, I know exactly what number I'm going to get back out. Now, sometimes I get 3 twice, but I know the one number that I'm going to get when I plug in a 5 is a 3. And the one number I'm going to get when I plug in a 9, well, that's also a 3. So let's take a look at the third example. So we could say it's the input and the output, or the domain and the range, but we're going to call it the x and the y. Let's see if this is a function. If I plug in a 1, I know I get an 8. If I plug in a 3, well, now I'm stuck, because if I plug in a 3, I could get a 6, or I could get a 4. So for this input value right here, I could get 2 different output values. So this example right here is not a function. And the reason it's not a function is because I don't know what I'm going to get when I plug in a 3. It could be 2 different things. So because of that one example, example number 3 is the one here that is not a function. Let's take a look at some same situations, except this time they're not listed as a mapping diagram. Let me write example number 4 as a mapping diagram here. So I have my input values, I'm going to put those here, and I have my output values, I'll put those here. When I plug in a 3, I know what I'm going to get is a 4. That's the first example. When I plug in a 4, I know I'm going to get a 6. When I plug in a 5, I know I'm going to get an 8. And when I plug in a 6, I know I'm going to get a 4. So this one is a function because I know exactly what I'm going to get every time I plug something in. Let's take a look at example number 5. And again, I'm going to have my input values here, my domain, and my output values here, which is my range. When I plug in a 2, so far, I know I'm going to get a 4. Then when I plug in a 3, I know I'm going to get a 5. When I plug in a 2, well, I already have a 2 here, it says I'm going to get a 6. So I could continue here. In a 4, I get a 7, but this is not a function. And the reason it's not a function is because when you plug in a 2, can you tell me exactly what is the one number you're going to get? And sometimes you get a 4, and sometimes you get a 6. And because of that, this example number 5 here is not a function. All right, let's see what this looks like in a situation of a graph. So let's take a look at example number 6 first. For example number 6, I'm going to start with this point. That point is the point -4, 1. Well, that means when I plug in a -4, the one number that I get is a 1. If I move on to the next point, if I plug in a -3, the one number I'm going to get is a 3. Notice that I'm putting all of my coordinates as an x and a y. And the x is this axis. So I'm going back and forth to the x and then up and down to get the y. And so let's go on to the next point. This is the point -1, 1. And I know when I plug in a -1, I get a +1. When I plug in a +1, well, I get a 2. And when I plug in a 2, the one number that I get is a 1. So every time I plug in a number, I know exactly what I'm getting. -4 gives me 1, 3 gives me, -3 gives me 3, -1 gives me 1, 1 gives me 2, 2 gives me 1. So this is a function. Now, let's take a look at example number 7. It looks like, so far, it's a function. When I plug in a -2 with this point, what I get is a 1. Then when I move to this point, when I plug in a 1, what I get is a 1. So I know exactly what I'm getting so far. But now when I plug in a 2, Well, if I plug in a 2, this is the point 2, 3. But then down here, this is the point 2, -1. So when I plug in a 2, I don't know if I'm up here at this point or down here at this point. So this one is not a function. Now, there's an easier way to look at a graph and determine whether or not it is a function or not. And that's called the vertical line test. If I go back to number 6, if I draw vertical lines on the graph, every vertical line hits exactly 1 point. If that's the case, it is a function. So far, on number 7, the first 2 points, the vertical line hits exactly 1 point. But here, a vertical line at 2 goes through 2 points. Because when I stick in a 2, I'm at a vertical line, and that vertical line goes through the point 3. So there's the point 2, 3, and -1. So that, because the vertical line test, if it goes through 2 points or more than 1 point, then that is not a function. Let's apply that concept to these graphs here. So number 8, without going through every single point, because I have a bunch of points here, I can just start drawing vertical lines. Does every vertical line go through exactly 1 point? And yes, it does. It either hits it here or here or here, but every vertical line hits exactly 1 point. So number 8, well, this one is a function. Let's move on to number 9. Number 9, draw a vertical line, and the very first vertical line that I draw, I can see it hits the graph twice. So when I plug in -1, I don't know if I'm up here or if I'm up here. For that reason, this one is not a function. And it would not be a function no matter where we were at. If I plug in a 5, which is right here, I would be at this vertical line, and I don't know if I'm down here or up here. So 9 is not a function. Take a look at number 10. Draw a vertical line, and you can see every vertical line that I draw hits 2 points. So again, this one is not a function. And then if I take a look at number 11, if I draw these vertical lines, every vertical line is touching the graph in one place. So number 11, this one is a function. So there we have some examples of what functions are. And that's similar to what you're going to be doing on your homework. We will see you tomorrow in class.